So hopefully you all got the software installed okay. We're now going to look at doing a little bit of very simple programming. So this is what we're going to create here is a simple latch like a motor start stop. So I'm not going to go into every function on this. There's timers and memory flags and all sorts on here, but I just wanted to give you really a bit of an example of how a PLC works. So let's crack on anyway and see how we do. Any questions, please do ask, and that includes if you've had any trouble downloading the software or installing it. This is probably about the most basic logic controller I've ever seen. Very inexpensive, but incredibly useful, as I've just found out on a project I've just used it for. So if we click here, we've got our inputs. So we've got input number 1. So these will be the physical inputs into the PLC. So this will be where if you get 24 volts on input number 1, this is this contact will actually react within the program. Like I said, it's easier to show you what it does than talk about what it does. So in here we will type start, and in input number 2 we shall type stop. So we'll take input number 1, highlight it, and drop it there. Now these symbols here, they're actually the American symbol for a relay contact, which has been adapted for ladder programming on all PLCs really. So that's what it is. We've adapted the American way on this one. So the next one we're going to put in is input number 2, which is a stop button. And then we're going to go to our outputs now. The outputs are Q, so Q1 will be output number 1. I don't exactly know why, but many PLC manufacturers use Q as an output. So rather than O-1, which I suppose looks like a 0, they use Q. So in here we're going to type motor. We're going to highlight Q2 and we're going to drop it in here where it says coil. That's automatically joined it up for us. Happy days. So the next thing we need to do to create this latch is to again take Q1, but this time we're going to make that an input down here. And then we're going to create this branch up here just by clicking on it to close it off. So what happens here is when I1 is made, this contact will close. It'll travel through this contact, and we remember that the stop button is normally closed, so this will be closed, and then this will energize this output coil here. And again, this is the American symbol for a relay coil. In the British or European, rest of the world standards, it is a rectangle. So this closes, and then any contacts that are assigned to this coil will also close. So we've reused Q1 down here, so this will close because this is closed. So now we've actually took us finger off the input, but the power will actually go down here, up here, and keep Q1 energized until we press I2. So when I2 receives an input, it will actually, when the stop button is pressed, it will break this contact here and break the circuit, and until we press the start button again, I1, it will stay off. So that's it really. That's our really simple program. So what we're going to do now is show how it works. So we're going to click up here at the top on simulation. We're going to click with PC. So now we can see to the right here that we've actually got an indicator of what ins and outs are actually being made. And then lower down here we can actually click these check boxes and watch it work. So the first thing we're going to do is click on I2, because that is a normally closed switch we're using for the stop button, just as we would in a conventional start-stop motor controller, direct online motor controller. So now what we're going to do, we're going to click on I1 and then click straight back off of it, just as you would a push button. So we make and we break, and we can see now that this I1 is gone off here. It's energized this coil here, which has energized that, and now this is keeping it on. It's actually latched on, so that's staying on. We can see over here that I2 is still made, and we can see that Q1 is made. So if that was hooked up to a motor starter, that motor would actually be running now, if that was energizing the coil of the contactor, if it was powering the motor. Hope that makes some form of sense. So now we're going to press our stop button. So we're going to, again, the stop button's a push button, so we press and then go back on again, and now we can see that Q1's no longer made. This contact down here is no longer made, and it's all ready for restarting again. The latch is broken. So again, we press I1, back off again, it relatches it back on, Q1's made, our motor's running. And that is a little bit of PLC programming demystified. That's literally how simple it is. So you've got an input and an output here. Now there's lots of things we can actually do with this. We can have timers there to switch it on, so we could have the motor running for a short length of time and then automatically switching off. So if we come out of simulation mode now, I'll show you quickly how to do that. So if we click on our timers here, so T1 will make sense, so we'll put run time in that. We'll take that contact here and plunk it there. I'll right click on this block, and what we're going to do is change that to being normally closed. And then we're going to take T1 down here, to add it underneath here. It's gone and filled that line in, which I really didn't want. So if we just click on these again, it will delete this line here. And then we want the actual line to go up here. So what will happen now, when I1's pressed, I2, that's the closed stop button again. And because this is normally closed, so it's closed until it's energized, the power will go through here, energize Q1, energize this contact, and that will keep it latched on until we press the stop button or the time runs out on this and it actually changes the state of this to open. Now, one thing we do need to do with this is to right click on it, go down to properties, so we can see that we want it to be a on delay timer. So it's going to wait X amount of time, which we're going to set lower down here, and then it's going to energize, and then any contacts that are assigned to it, just like the coil, will operate. So we've got the choice of seconds, minutes and seconds, whatever else. So we'll delete that and we'll put 10 seconds in there. We'll OK that. So once this is energized, it'll energize this coil, come down here, start the timer running, it'll run for 10 seconds, and then it will break this contact here and the motor will go off automatically, hopefully. So again, simulation mode with PC, we'll make input 2 again, because that's the closed, it's normally closed switch, not normally closed contact here, it's a normally closed switch which will close this. So now we're going to press I1 again and off. Let's see if our 10-second timer works. It should go off. There you go. It's actually broken that. So Q1 is no longer made. So a simple push of a button will allow this motor to run for X amount of time. In our case, 10 seconds. And that's it. That's a really simple program with a timer on there, just to show you how those two work. These PLCs are 85 quid plus VAT. You can have a number of timers on there, number of outputs. You got actually, what is the 5 outputs, 8 inputs? I think it's actually 6 on this one you're allowed to configure. But yeah, you know, you've got yourself if it was a push button light switch, for instance, you know, bottom of the stairs, press I1, you've got yourself a stairwell light timer. You might want a bit more than 10 seconds unless you're Linford Christie. And that's it. But you could also have a switch at the top. So let's say we were doing, let's switch this simulation off. So let's say we were using it to control the lights on the stairs. We could actually use, again, we'll go to another input. So we'll call that start 2 in our case. So we'll plonk that down there. Apologies for the dog. Plonk that there. Go back to simulation. So now we've got an upstairs and a downstairs switch. So we could make I2 again. So now we've got the upstairs switch to switch these lights on for 10 seconds. So again, Q1's latched on, the coil's on, our lights are on, the timer's started. I'm making a quick dash up the stairs before the lights go out, and now they've gone off. So that's just a really simple use of this type of circuit. We've got ourselves a really easy, inexpensive stairwell timer, two-way switching. That's it, folks. We'll look at some more examples later. Thank you.